All right, so we're going to write expressions that model the given context. Give your answer in the simplest form. So on all these examples, we're writing equations that when I plug in a value for a variable, it gives me a total number of something. So in the previous examples, it was like I had to buy a certain number of package of pens and pencils. So then I would plug in the total number of pens, and then that would help me calculate the total cost. We did another example where it was like the total bill for buying watermelons and stuff like that. So this example says the number of gallons of water in a tank already has 300 gallons in it after being filled at 35 gallons per minute for m minutes. So that expression, I have 300 already, plus 35 gallons per minute. That's it. That was pretty easy. Next one, the original price P for an item less a 5% or 15% discount. So what's the price P? Minus 15% discount. So remember on the other one, what we did is we take 15 and we make it a decimal by moving the decimal 2 spots to the left. But we also have to multiply that by the price. Now, if you think of this as 1p minus 0.15p, you could think of it as 1 minus 0.15p using the distribution property in reverse, or 0.85p. 1 minus 0.15. Let me double check that on the calculator. I'm pretty sure that's right. But whenever you're not sure of what the number should be, at this point, double check it on the calculator. So I'm going to say 1 minus 0.15. Yep, 0.85 it is. Okay. Any questions on that one? Let's do some more. Problem number 11, it says, when given an algebraic expression involving subtraction, why is it best to write the expression using the addition before identifying the terms? So this is a conceptual question. I think what they're talking about is what you're going to do is you can write, well, let me change the color on that. Let's change this to black. Write, I think this is what they're saying, write subtraction as the adding of a negative term. And so when you rewrite all subtraction as an addition of a negative term, it helps, this is what the textbook says, helps to avoid errors. Because what happens is people forget that that's a negative number, right? We were talking about, x minus 3 and then y plus 2. Well, if I say, well, help me identify, or better yet, x minus 3p. So, for example, if I say something like x minus 3p, they're saying that you should write it as x plus negative 3p. And the reason for that is if Mr. Adams says, hey, what's the coefficient of p? A lot of kids, if they look at this, they'll say, oh, it's just 3. But it's not. It's really technically negative 3. So when you rewrite it as an addition of a negative term, you're less likely to get that coefficient wrong. Because we'll use formulas in Algebra 1 where they want to know the term, and you need to know that that's negative 3. All right, next question. How do you interpret algebraic expressions in terms of their context? You just have to identify the parts. So if I say 3p plus 4q, or 4g, it doesn't matter what it is. 3p represents 3 times p. P could stand for, P stands for something, right? 4g, this is the same thing except it's 4 times how many g you have. So P could be, what do you want P to represent? And be school appropriate, please. Sure. P could be the number of peanuts. What do you think G stands for? Could be bags of peanuts, but you get the drift, right? We're counting how many peanuts we have, some way, shape, or form. What do you think G stands for?
Goblins.
Not goblins. Let's come up with something a little better.
Games.
Huh?
Game.
How about games? So let's say you go to the fair and they charge you $4 a game, right? So this could be $4 per game, and you want to eat peanuts while you're there, and they charge you $3 for a bag of peanuts. Well, this is an expression that'll tell you how much your total bill will be. Does that make sense? So when they talk about having something in context, you have to look at the terms, right? This term represents 3 times the number of bags of peanuts you have. This term represents 4 times the number of games that you play. Your total bill will be us plugging in a value for P and us plugging in a value for G, and that gives us a total number when we're done. Okay, let's do problem number 13. Problem number 13, it says, how do you simplify algebraic expressions? Most of the time, you'll hear me say this a lot. You're going to combine like terms. Another thing that we'll do sometimes is we'll use the distribution property. The distribution property is something that we do. What else do we do? I mean, those are the 2 main things. Sometimes we'll do some algebraic stuff, which means we move stuff to the other side. But when you simplify it, and I want you to write this down. It may not make sense, but say upside down triangle, or sometimes I'll call it a Christmas tree. So sometimes you'll get something like 3x plus 2x plus 3 plus 1. So then I'm going to combine like terms. So I'm going to take the x's and add them up. I have 3 x's in my hand. I add 2 x's to it. That gives me 5x. Over here, I've got 3 plus 1 is 4. And so what I've done is I have effectively taken something that was wide, and it starts to look like an upside down triangle, right? And if I know the value of x and I plug the value of x, it comes down to like x equals 2 or something. So when you take algebra, you're going to have these long expressions, and you're going to use the order of operations to kind of make them smaller and smaller and smaller. And when you write every step out, it looks like an upside down triangle. Okay. One last question for this thing, and then we'll let you loose on the homework. It says, how do you write algebraic expressions to model quantity? Well, I'm going to write this in steps, okay? So step 1, identify parameters. parameters, and we'll call that a variable. And so that means that you're going to measure stuff. I got to spell variable right. But what is measured? Or counted. Step 2. Determine the value. And I'm going to use a fancy math word. Per unit value. How much is it for a head of lettuce? How much is it for a bunch of bananas? What apples per pound? Loaf of bread. How much is it per one loaf of bread? $3. Well, those are the two things we need to identify. What is it that we're measuring or counting? And what is the value of it? And then the last one is think about the math operations. Do you add them? Do you subtract them? Do you multiply them? Do you divide them? And that's it. Those are the main things. And usually they're done in this order. You could do them in, I'm sure that I'll have a student that'll try to do it backwards or do it whatever. And if that works for them and they're able to keep track of it in their head, that's fine. But most people will go, okay, what are we counting? Well, we're counting tomatoes and cucumbers. All right. Well, let's call the tomatoes T, and let's call the cucumbers C. Well, how much is it for the tomatoes? $2 a tomato. That's kind of expensive. 50 cents a tomato. And the cucumbers are $1 a cucumber, or whatever. Whatever it is. It could be per pound, whatever. And then I'm gonna add them up. And I'm also gonna multiply some numbers. So I'm gonna have a coefficient and all that stuff. But that's basically the process. Okay? That's basically the process. Do you guys have any questions on anything? All right, I'm going to leave this up for a second.